Okay, hello everyone. Back to another exciting video involving math. Yay. Okay, so here we are starting a new unit. This unit is polynomials. This specific section starts a two-section work and look at exponents. So we're finished with linear functions. We're going to move on and look at polynomials. And to first understand polynomials, what we need to do is to better understand how to multiply, divide, and raise to a power exponents. So today we're going to be looking at multiplication and raising to a power. So to do that, if I want to discuss something in expanded form, so a power in expanded form, what that means is that we're representing a term with a written exponent using multiplication. So let's look at an example so we can see what that means. 7 quantity cubed in expanded form is just 7 times 7 times 7. So we're representing it using multiplication, which is equal to 343. Or you can write using algebra, 7 cubed is equal to 7 times 7 times 7 is equal to 343. So knowing expanded form, let's take a look at some products of powers, okay? And we'll look at that using expanded form. So just to be clear, if I am saying 2 squared times 2 to the 4th power, this 2 squared is these 2 times 2 times 2. Sorry, 2 times 2 here. This 2 to the 4th power is these 4 2's. 2 times 2 times 2 times 2. So in expanded form, we write 2 squared is 2 times 2. 2 to the 4th power is 2 times 2 times 2 times 2. And how do we write this as a single power? Well, how many 2's are there? If I'm going to write this using a single power using exponents, I write this as 2 to the 6, right? So 2 to the 6 here. Let's look at some other examples involving expanded form, and you'll begin to see this pattern emerge more. So we have 5 cubed times 5 squared. Whoops. I want to just rewrite this. I want to write it in expanded form. So 5 cubed times 5 squared. That means that there are 3 5's. That's 5 times 5 times 5. 5 cubed times 5 squared. Tack on 2 more. How many total 5's are there? Well, simply 5. My final answer is a single power. 5 quantity to the 5th power. X to the 4th times x to the 7th. Well, that's simply just 4x's. 1, 2, 3, 4. Times 7x's. 1, 2, 3, 4, 5, 6, 7. Because really, remember, x to the 4th is just x times itself 4 times. So same thing with x to the 7th times itself 7 times. So how many total x's are there? Well, x to the 11th power. And lastly, we'll do a to the 6. So first I'm going to do 6xa's, sorry. So there are 6 of them here. That's a to the 6th power. Tack on 2 more. How many are there? A to the 8th. Okay, so you should probably see a pattern emerging here. And let's take a closer look. This pattern is called the product of powers property. A is a real number, m and n are positive integers. If I were to write this in words, I'm going to say to multiply powers having the same base, you add the exponents. And note, this should be obvious to most, but I just want to be clear. I won't define what an exponent is, but when I'm saying x quantity squared, right? The base here, this base is x, okay? So the exponent is 2. The base, when I say base, that's what I mean. That's x. And so let's look at the algebra here. So to multiply powers having the same base, you add the exponent. So a to the m, where a is a real number and m and n are integers for now. A to the m times a to the n is equal to a to the m plus n. So let's just take a look at an example here. All I want you to do is just write this out in terms of the addition problem that it is, in that if I am trying to write x squared times x cubed, right? That's equivalent to x to the 2 plus 3 is equal to x to the 5th. So that's all I want you to write. Basically, all you're saying here is that x squared times x to the 3rd, I'm just adding these exponents to come up with my final answer. So let's take a look at a couple more examples. Maybe say something like b to the 11th power times b to the 12th power. Well, that's just simply b to the 11 plus 12. What's 11 plus 12? b to the 23. Take a look at another one. How about y to the 7th times y to the 6th? What is 7 plus 6? Right? Y to the 13th, etc., etc. All right, so everybody should get the hang of that. I want you to take on some your term problems that have to do with the product of powers property. So let's take a look at another sort of pattern that emerges here. If I were going to write this expression, and it's 2 squared quantity cubed, meaning 2 squared times itself 4 times. Note that that's represented up here, and that is 2 squared times itself 4 times. So this 2 squared 4 times. What's 2 squared? Because that's 2 times 2. I'm just writing 2 times 2 4 times. So 2 times 2, 2 times 2, 2 times 2, 2 times 2. Now, how many 2's are there here? Well, 2 to the 8th power. There are 8 total 2's. So let's take a look at another pattern that's emerging. Well, what's 5 to the 5th power? Quantity cubed. That's just simply 5 to the 5th power times 5 to the 5th power times 5 to the 5th power. That's a 5. And note that I said 5 to the 5th quantity cubed. When you want to describe something being raised to the power, you say whatever is inside the parentheses first, meaning I said 5 to the 5th, and then you say quantity, whatever is raised to the power. In this case, it's cubed, but you can say 5 to the 5th, quantity to the 4th power, 5 to the 5th, quantity to the 20th power, okay? So that's what I mean when I say quantity. Now let's write this out. There are 5, so we have 5 5's, essentially, multiplying by itself. So it's 5 to the 5th power 3 times. I'm going to do that then 3 times. So another 5, and then another 5. And I ran out of room, so let me write another 5 here. How many total are there here? Well, 5 to the 15th power. Same thing with x to the 3rd power. And that, okay, let me write this up here, actually. This is really x cubed times itself 4 times. So what's that? That's this x cubed, x times x times x, a second x cubed, x times x times x, a third x cubed, and then a 4th. How many total x's are there here? There is, whoops, that's not x to the 4th power. That should be x cubed. Let me rewrite that. X quantity cubed. How many total x's are there here? Well, that is definitely an x. How many total x's are there here? X to the 12th power. Okay, so let's define this rule. This is called the power of a power property. So in words, we can say this. To find the power of the power, you multiply exponents. This algebra is a to the m raised to the n power, or quantity to the n power, is a to the m times n. So I'm multiplying exponents. And an example would be something to this effect. Okay, I'm going to write it out using multiplication, the same thing as I did before. How about if I said, what is x squared raised to the 3rd power? Well, that's just simply x to the 2 times 3. What's 2 times 3? X to the 6th. Okay? So all of these can be sort of proved using expanded form. Let's get some practice in. Using the power of a power. So let's say, what is x to the 6th quantity squared? Well, that's x to the 6th times 2 is equal to x to the 12th. Let's do another one. How about, what is y to the 4th power raised to the 30th power? What? So big. That's okay. Y to the 4 times 30 is equal to y to the 120. Okay. Now, let's try some your turn problems. I want you guys to tackle these on your own. Okay. Last property we'll be learning today. Another pattern that's emerging. If I say xy quantity squared, right? That's xy times itself. If I reorganize this through the what? Give you guys a second to answer in your head. What property am I reorganizing the xy times xy to x times y times y? If you said the commutative property of multiplication, then you are correct, sir. Actually, you can think about it as the associative property as well, too. Yeah. Community is happening individually. At any rate, it doesn't matter. I can reorganize this x and that x to make these x's, and then this y and that y to make this y, right? So then what is that really? That's x times x squared, and y times y squared. So let's take a look at this as well. What about 3x quantity cubed? Well, that's just simply 3x times itself. 3x times 3x times 3x. And what is that now? Well, if I take the 3's and I group them together, and I take my x's and I group them together, then what could that be? Whoa, that is 3 cubed, no, equals. We are going to figure out what that equals in a second, but let's physically write the last part of the term there. So that's 3 cubed, right? X cubed, which is, okay, what is 3 cubed? Let's see. 3 times 3 is 9. Times 3 again is 27. My final answer, 27x cubed. Okay, good. All right. Same thing for 9xy. What is that? That's just 9xy times itself, okay? Twice. Which is then what? Well, I'm organizing the y's together. I'm organizing the x together. Same thing with the other y. Wow, that is the world's worst y. Let's pretend I never wrote that. Okay, and then I organize the second y, and what is that really? Well, that's just simply 9 squared, x squared, y squared, which is equivalent to, because I have to simplify this 9 squared, 81 x squared, y squared. So let's get some, take a look at what this power property is called. So this is power of a product. So a be a real number, n and m are positive integers. So what's the words here? To find the power of a product. So a product inside parentheses. You find the power of each factor and multiply. So what's that algebra? AB raised to the m is a to the m, b to the m. So let's take a look at an example here. Really, essentially in the table, we looked at examples of this as well. But let's say I want to have 2x raised to the 4th power, okay? Well, that's just simply 2 to the 4th, x to the 4th. And we said before, how do we simplify 2 to the 4th? That's 16, x to the 4th. So let's take some more practice time here. What about 3xy quantity cubed? I know that this is 3 cubed, x cubed, y cubed. 3 cubed, I think we looked at this before, is 27, x cubed, y cubed. Another one, how about let's do 7x squared. And this is going to be 7x squared. What? No, that doesn't make sense. Yes, you're right, that doesn't make sense. Very common mistake here by students. This is why we're addressing this property. Don't forget to square the 7 as well, too. This is 7 squared x squared, which is 49x squared. So you're not just squaring x. If the entire thing is in parentheses, you have to square 7 as well. So that's the point of this property. All right. I want you to practice with the your turn problems. Oh, well, darn. This your turn is the exact same one I just did randomly. Let's go ahead and say that I'm going to change this one. Let's erase this. And I will come up with a new one. So I can tell you did this by doing my your turn that I'm about to write in and not the one that I just used. It's amazing how the brain comes up with the same thing again and again and again. All right, so how about 2x raised to the 5th power? So you try that for the your turn. No, 2 to the 5th power is not difficult. Just keep multiplying by 2. Okay, right. Now, let's sort of put it all together here. So how do we do this? If I'm multiplying, okay, so here I'm potentially using a sort of a more difficult version of what we did before with an extra step and maybe multiple power rules at the same time. So I'm multiplying negative 8 m to the 4th power times m to the 3rd power. So what is this really? Now note when I'm multiplying these two terms, this coefficient to m cubed is 1. When I multiply these two, I just first multiply my coefficients here, negative 8 and 1. So that negative 8 stays here, and this becomes m to the 4 plus 3. So this would simplify to 8m to the 7th power. Same thing here. Now note in my rules, order of operations, I need to deal with exponents first. So I'm keeping 60 squared for right now, okay? And dealing with 2d to the 5th raised to the 4th power first, okay? Because I need to clear my exponent values before I start my multiplication. Now, What's 2 to the 4th power? 2 cubed is 8 because 2 squared is 4 times 2 is 8 times 2 is 16. So this is 16d. I multiply these exponents because I'm raising a power to the 20th. Now I can do my multiplication here. So I need to do 6 times 16, which is 96. And d squared times d to the 20th power is d to the 22 because I'm adding my exponents. So this is an important component of what I did here. And I just want to emphasize this again because I know students are going to be asking me about this come practice time. When I'm trying to multiply these two and they both have different coefficients to d, my first step is to just simply multiply my coefficients. 6 times 16 is 96, right? And then I can multiply my exponents. So I'm using my exponent rules to multiply d squared and d to the 20th. I'm using just standard multiplication to multiply their coefficients, all right? So that's important to keep in mind. So that concludes our video. I want you to try these your term problems as well too. These shouldn't be that challenging for you. Today's topic is relatively easy. I want to see that everybody completes every single your turn problem, at least has some writing on the paper. I'm tired of seeing blank your turns given the performance on the last 2 quizzes. I need people to be practicing from these videos at home. If you need to go back and review what I just said in the example or anything I did, try to understand it on your own. Ask me questions via Edmodo. All of that is relevant. So try these your turn problems on your own, and I will see you on Monday. Okay, bye.